Hey everybody, welcome back to GR Research, where today we're going to be looking at this little B&W speaker. It's a CDM 1NT. I know it's an older model, but it's one of their better older models. And sometimes it's better to take an older model like this and retweak it and make really a better product out of it than you could get if you were to buy a new speaker. So let's take a look at this thing. This thing had some pros and some cons to it, really, I think. The cabinet-wise is built pretty well. I mean, it's 3/4 inch MDF. This is raw MDF on the sides that is just stained to match the wood, and it actually looks really well. It is braced. There's one brace running through it. I do like the tweeter and the pod concept. I like the fact that we're minimizing surface area around this tweeter, and that does improve transparency and the three-dimensional sound field, because we're doing away with that sound as if it's playing from the baffle forward. So I like that. But there's some things that I didn't like about it. And let's look, well, you know what? Let's look at the woofer. It looks like a well-made cast frame. It looks nice, and I like the material somewhat. It can have a fairly decent sound if treated properly. However, man, this thing has some ringing to it. Oh my goodness, I hate it in a way. I hate the response on this woofer. And you know, before we even get into the measurements on this thing, let's look at the frequency response of just this woofer. I'm going to have Ron throw that up there for you guys. Yeah, oh man, look at that big old peak up there at 4,000 4,000 hertz. Oh, you know, I design a lot of drivers for companies, and I design our own drivers, and I'll give one of our manufacturers a list of specifications that I need met. I choose the materials and things that I want used from it, and sometimes we'll base it on something we've already done. I'll say, let's take this, and we're going to change it and add that. We're going to make a higher Q version for open baffle or something. So, and then I get a sample from them. And then I measure and test that sample, and I say, great, this is perfect. Or I usually say, no, we're going to change this, or we're going to change that. We've got to fix this issue to make it to where it's easier to work with, or has a better sound, or has a smoother response. In this case, if they would have handed me a woofer that had a response like this, I would have said, you have got to be kidding me. Go back to the drawing board and let's fix this issue. Now, this frequency response was a mess, and it also showed up in the frequency response of the speaker. Let's look at them. Let's look at just the on-axis frequency response, and as you can see, it's a little wavy. It's a little rough. There's definitely some peaks and dips there. The biggest dip being right at the crossover point, which is around 2,500. There's a bit of a hole, and there's peaks on either side of it. The worst is the peak right at 1,000 hertz, and that's from the ringing of this woofer. So looking at that, let's also look at the frequency response once I took the grill off. So the first one you just got to see was with the grill on, and the grill just comes right up to the tweeter level there, and it's kind of cut away so that it doesn't get into that. And it's a fairly well-made grill, but however, this frame around it is a bit of a problem. So it does have a better frequency response with the grill off, even in the tweeter's response, because like I said, the surface reflections are a big deal when it comes to tweeters. And if I can get this thing kind of lined back up here without my glasses on so you guys can see it, there's this area right here on the front, and the tweeter's response reflects off of that, and that's what causes that choppiness up front. So removing that produced a better response. So let's look at the frequency response of the individual drivers and then summed. First we'll look at it with the grill on, and then with the grill off, and it definitely looks better with it off. However, as I look at the frequency response of this thing, I have to just shake my head, and I think, B&W, what are you guys thinking? What are you thinking here? there's that big peak at 1 kHz that's caused from the woofer, and there's this big hole there, and as you can see, where the tweeter rolls off and then the woofer rolls into it, they're not really summing properly. In other words, they're not in time. One is arriving a little different in time versus the other, so they're not in phase. It's disrupting the response. And I have guys, when I do these upgrades, I have guys that'll comment, and they'll comment on, all you're doing is making the frequency response smooth. Maybe that wasn't the original intention of the designer. Maybe they wanted it that way. And I always get a kick out of that. Yeah, like they had a smooth response, but they thought, you know what, accurate isn't what we're aiming for here. Let's cause a hole in the response by putting a filter in there that will keep the drivers from arriving in phase, and the time alignment, the time arrival will be a little bit one behind the other, and instead of summing, they'll be 90 degrees out of phase. So there'll be a 90-degree phase rotation. So we'll have the tweeter's response, the woofer's response, and then the frequency response just follows that curve. It never sums. No designer ever thinks, hey, let's cause a time delay problem, let's cause a phase shift, or let's cause a big hole in the response because that is going to sound better. No. No one ever does that. No designer targets those kinds of parameters. They look for trying to make, if they're doing their job, trying to make the time arrival so that they sum when they cross. So we have tweeter's response, woofer's response, tweeter's response, and then where they drop, they sum, and it makes a flat frequency response. That is what typically designers and engineers target, because that flat response is going to accurately reproduce the input signal. So in this case, yeah, come on, B&W, what are you thinking here? This does not sum well, and if we look at the spectral decay, this is my favorite measurement to look at. If you want to know how a speaker is going to sound, look at the spectral decay, and you'll see right there in the woofer's response, there's a little bit of ringing there. It's not bad. It's not as bad as if we let it play to 4 kHz way up there. There'd be a lot of ringing, but there is some ringing right there in that one spot at 1,000 hertz. So what does that sound like? What does that sound like? When you're listening to a speaker and you hear that residual ring on each note, it is a form of distortion. And I know you guys often want to throw out those terms like distortion. What's the distortion like? And I can tell you right now, when you're actually measuring distortions from a harmonic standpoint, when you're looking at total harmonic distortions, the differences between 1% and 2% are negligible. That's not something you're going to hear and you're going to think, man, that one sounds awful. That one sounds great. It must have lower distortion. No, those numbers, when you're down there at a low level, those numbers really don't indicate a difference in quality or difference in the way they sound. Now, if there's a problem and you see distortion shoot up somewhere in one spot, that's a red flag that there's a problem there, and that problem could be audible, and it's also going to show up in other measurements. But anything that's a variation of the input signal, where you've got an input signal and then you're reproducing something else, that's a distortion of the original signal. So anything that's not accurate can really be considered a distortion, especially in the spectral decay. When you look at that spectral decay and you see, that's when you're hitting the speaker with an impulse, and then the impulse stops, and what you want is the speaker to immediately stop. What you don't want is for you to see it in one range. You see a long trail of ringing. And remember that we're just measuring it at 1 watt, 1 meter here. So we're not really hitting the speaker with a lot of power. So when you see 5 or 6 milliseconds of decay in one area, that's pretty significant. That's a residual ring that you're going to hear. And when you ramp up the wattage, so you're outputting, or you're driving it with more power, and you're outputting a greater SPL level, that ringing is going to be considerably longer still. Now you're really exciting it. It could be 10 to 20 milliseconds of ring. So that's a huge distortion, and it overwhelms any of those numbers you're going to see in total harmonic distortions by taking that type of measurement. these are more telling of what is going on. And we see a little bit of that right there. Now, let's look at the vertical off-axis. That means we're going to take the microphone and we're going to move it up vertically. And when we do that, we notice a pretty deep suck out in the response. That's because the time arrival as you move up, and you're making the woofer further away in time than the tweeter, and with them not in phase, they're causing a cancellation. In other words, right there, they're out of phase, and there's a hole in the response. So if you're listening to the speaker and you stand up and you sit down and you stand up and you sit down, you'll notice the high frequencies through that range there completely drop out. And you have to remember that a total in-room response will sound uneven as well, because you're getting ceiling and floor reflections that are not as even as the on-axis response. You want a speaker to deliver a response evenly throughout the room, and then you're going to hear a more even and more balanced response. You don't want a hot spot or a spot where you're getting high frequency reflection, low frequency reflection, and nothing in the middle. It's going to have an imbalanced sound. Looking at the horizontal off-axis, we see, because there's nothing around this tweeter, we see it drop off rather smoothly. We don't see a lot of surface reflections that are causing problems in that response. So it looks pretty good. We already looked at the woofer's response. I had to just get right into that immediately. If we look at just the tweeter's response, it's not bad. So it gave me something to work with, but I knew I was going to have some problems with this little woofer. I was going to have to add some notch filters and do some things a little aggressive to fix that. So let's look at the new frequency response. Now we're talking accuracy and nice and smooth. Does that mean it's going to sound better because it's a flat response? No, it means it's going to sound more accurate. That means it's going to be more true to the input signal. Is that better? Yes, that is better when you don't have errors. It's the errors where you've got time arrival effects where one is out of time with the other, or you've got a hole in the response or something like that. That does not sound better. You know, when you can deliver a level of accuracy, that's always going to sound better. It doesn't mean that because it's a flat frequency response that's going to sound flat. It has nothing to do with the dynamics of the speaker or how a speaker is going to handle a transient response or anything like that. It isn't going to sound dull because it has an accurate response. It's just going to sound accurate. The speaker can have an accurate response and it can sound dull, or it can have an accurate response and it can sound like live music in front of you. Those are completely different issues. The frequency response being flat is only a measure of accuracy. So let's look at the frequency response of the individual drivers and how they're summoned. Notice I let that tweeter play on down a little lower and dropped it off a little more steeply. Same with the woofer. I had to get a little more aggressive with the filter. Get that ringing up top taken care of. And you'll notice right there at 1 kHz, I got a little notch filter in the circuit and it's pulling that down and keeping it from ringing so much in that range. So let's look at the cumulative spectral decay. That was kind of a mouthful today. Let's look at the spectral decay, and you'll notice that I got most of that out of it. There's still a little bit going on there in that range, but it's a little bit better than it was. So it's going to have an easier to listen to sound. Over time, it's not going to grate on you and feel like, oh, I just need to turn that down. That's usually what happens when you have a bunch of ringing, is you feel like you really need to just turn it down because that residual ring becomes an irritation. All right, let's look at the vertical off-axis again. Now, the vertical off-axis has changed because I've changed the crossover point and I've changed the order of the filter. And as we go up and down, it maintains a little more consistent response. We still got a little bit of a dipped area there, but it's less than half as bad as it was. The horizontal off-axis, again, rolls off really smoothly. And we've got a little bit of a peaked area right there around the crossover point, maybe a little above it there. And it kind of mirror images the little bit of a dipped area that you get in the vertical. So as you go up and down vertically, you're changing the time arrival of those drivers, and you're seeing a little bit of a dipped area there. But as you go left and right, it starts to drop off in output pretty evenly, except in that area. So the overall balance, when you take a room response into account, is going to be really balanced now, because the horizontal and the vertical are kind of offsetting each other in those opposite directions. So they kind of counter each other out in a way. So not bad. Impedance response is balanced now after I've built a new network for it. Tuning is the same. And let's look at what we wound up with on this thing. Let me put the reading glasses on here. I'm going to have to do a little reading. All new crossover parts and a set of tube connectors, which it really needs. These binding posts on the back of this thing are fairly cheesy. These little plates that you put from one to the other to connect them, not something you want in your signal path. Replace one set of those with a set of tube connectors. You can parallel the other one up to the tube connectors. That way you can use either or. I love it when you guys do that because you always respond back to me and say, hey man, it sounds a lot cleaner with those tube connectors than if I go down to the binding post. And yes, it does. And I appreciate all that feedback whenever you guys do that comparison and you let me know what's going on. And you hear that difference. I appreciate you guys letting me know that you're listening and you're getting it. That's great. Also, all new wiring. I did not include a sheet of no-res in this. It was not vital that this one have a sheet of no-res. It's braced okay. It would help if you want to add that to it, but I didn't include that in the price on this one. Total price is $310 for everything you need to upgrade this thing, and that's all new parts, bigger air core inductors. It is using all polycaps, and it's using a Sonicap in the tweeter circuit and much higher quality resistors than what's in here. These are our little sandcast resistors, which is kind of a bummer, but it's very typical. They did use polycaps in this one, and they did use air core inductors. So kudos to them on using some decent parts. They just didn't do their design work very well on this model. So a little tweak here and there balances this thing out, and the upgrade in the parts quality, especially that Sonicap in the tweeter circuit, upgrade in the wiring, upgrade in the connections, all that's going to be huge improvements in clarity, and it's going to turn this thing into a whole lot better sounding speaker. Another thing I'll mention too, to work on this thing, the tweeter has a bolt through the middle here that holds it on. You have to unbolt that, and there is a plug that plugs their original network into the tweeter, and that wiring goes up into the tweeter, and you really can't access it. So in order to implement this upgrade, you're going to have to cut the wiring coming off of that after the connector, and you're going to have to connect new wiring to the old wiring right there. So you're going to have a little bit of short old wire that you'll connect your new wiring to. That's the only way you can connect the new crossover to the tweeter. You're still going to have to use some of that original connection there. The woofer, on the other hand, it's got the push-on terminals, and it had push-on tabs on it. Boo! And so you can solder right to that. It should be a pretty easy to implement crossover. It's not terribly complex. It does involve some parts, but it's something you can build on a new board and mount it in the back of the cabinet and wire everything up. It should be a fun project, not a too difficult one. I'd say novice level, and it will transform the speaker. So if you own one of these and you want to do that, that's great. If you have other speakers, I know you're constantly messaging me about this speaker or that speaker and sending me speakers. I love working on these things. It's a lot of fun, but we're 5 to 6 weeks out right now on things I need to work on. In other words, there's a lot of design work lined up, and I try to get to it in the order that it came in. So you might want to check with me before you send something to me, and hang in there with me a little bit. Once we start getting a little more caught up, then it'll go a little more quickly. We're in a transitional period still. We're doing new construction, and we've got some new employees, and everything's 100 miles an hour, and I appreciate that I could sneak over here into the listening room and shoot some videos where I'm away from everything going on over there. So, again, thanks for watching all the videos. Hit the subscribe button, please, if you haven't. We've got some more coming up, and something a little different even. So hang in there, and thank you for watching. See y'all.